Hello, welcome back. Today we're going to revisit one of the questions we have previously done before, group anagrams. So given an array of strings, we want to group the anagrams together, and we are told that we can return this answer in any order. So we know what anagrams are. They are basically letters that are rearranged, but they use the letters of the original letters or exactly once. So for example, TEA and EAT, they both contain the same letters. So we're given an array of strings, right? And here we want to group them. So BAT comes together, NAT, NAT. And so we are supposed to output an array of arrays or list of lists, right? And then here we have this, we want to group it like that and like that, right? So basically, when we're looking at this question, we have two ways of looking at it. The first of which is we can think about sorting the strings, right? Obviously, to determine if two strings are an anagram of one another, we know from a previous example that we did before, we could, given two strings, we can use a hash set to determine if they are anagrams of one another, right? However, if you want to use that in this case, you will need to, right? But if you call this function, let's say this function is f, right? F, you end up with O(n) squared solution, right? Because of the fact that you have to compare every single pair with each other, and immediately you think, for example, you call f0, f1, and then f0, f3, f0, f4, and then just compare with a double while loop, right? You basically need a double while loop. So now we can think about doing better. So can we do better? Obviously, there is a better solution to check whether two strings are equal. So what we can do, in fact, is to sort each string, right? To sort each string in ascending order, which is basically the ASCII order. So in this particular case, we have this, right? What will happen is that we will end up with AET, right, as the sorting, and this will be AET as well, right, and this is ANT, and then AET as well. So, and so on and so forth, right? And then using string equality, right? Use string equality to check each value, right? So you have this, you run through, you can use a hash map here, hash map to check, right? So basically you have hash map, and then you have these you sort the entire thing like that, and then essentially you have equals, so you have AET as one of the values, so you have AET here, and you would probably put something like this here, right? And then here you will run the function, right? You have an equality check. If the value is equal, for example, EAT, the sorted value, right, is equals to AET, you would enqueue this. So it comes to this next value, TEA sorted is also AET, so you enqueue TEA, right? And then when you come to a new value like TAN, you would first find out if TAN is a value of this, right? It's a key of ANT is a key. If ANT is not a key, you will add it to the hash map and then initialize this with TAN, right? And then the process just goes on. And so what's the time complexity of this particular solution? Let's say the average length, right? The average length, right? M be the average length of each string, right? Then you need to sort each string. So the time taken to sort a string would be M log N, right? And then since you have let N be the average length of the strings array, right? So this solution would actually end up being M log N, right? So again, since we are familiar with this question, we want to know whether or not we can do better, and this is where we need to think of something creative and out of the box. So right here, right now, we can actually think of something else, which is to instantiate a new value, right? We want to actually have, right? We want to use, right, as a hash array of letters, right? We want to use an array of letters. So for example, array of all letters in the alphabet. For example, we have A, B, C, D, E. Initialize an array, right? So we have something like this, and then we have and so on and so forth, right? So this is essentially what this array represents, this 0, right? And 0 array of all letters in the alphabet. And then when you come to one of these values, right, you want to iterate through the elements and then you add them in. So for example, right, for example, for EAT, what you want to do, it will end up with is 1 here, 0 here, 0 here, 0 here. And for E, you want 1, and somewhere along the line, you have 1, right? So somewhere along the line, you have T, right? So when you have this, when you fill in this value here, you can then know whether or not this particular value is a anagram of another value, very simply by checking this array here to represent this value. So EAT will be converted to this particular array, right? And T would also be converted to this array. So we can actually use this value, right? Use this array. We want to use this array as a key. Going back to this particular topic, right here, if we want to skip the missing step, right? If we want to optimize this solution, we probably want to skip, right? Skip sorting to make it a linear time algorithm. So if we don't, with this particular solution, with by being able to represent each string as a new key, right, we are now able to skip the sorting of that particular string, and hence this particular solution would end up as ON solution. So why is this O of n? Hold on, let's just trace this through first. So we have a string here. So for example, we would start off with ONT, right? EAT, and this one is like T. Let's just put it here, something like that, right? A equals 1, and then B, C, D, E equals to 1, right? Something like that. You put this as a key, and then you have this, right? And you initialize this as EAT. Same thing, EAT, TAN. And then you have another one that is something like this, right? Initialize this key here. In the end, this is TAN, so TAN, somewhere in between. Right? Somewhere in between here, right? Then you have TAN. Essentially, this is representing TAN. And then NAT, right? And so on and so forth. Yeah? So essentially, this is the hash map that we want to use. And so what the time complexity of this solution is that to form each to form this hash map, this array of values itself, you need to go through m, right? M times yeah, you probably need to go through m times, right? And then you basically can go through the entire array once, right? Go through once, check, go through twice, go through thrice, go through another time, and another time, right? And this is probably linear time, because assuming the array is in n, assuming the average length of array is n again, n, and then you do a maximum of 26 times, which equals to O(n). Yeah, and this is much more efficient as a solution. Obviously, yeah, this is a pretty smart idea that we found from, in fact, consulting some other solutions on the internet. Yep, so without further ado, let's just start right away. So what we want to do, in fact, is to, right, and once we have this, we want to have this goes to default dict list, right? Because we want to initialize an array of these values, empty array in the case that the value doesn't exist yet, right? And then here we want to have for string in strings, right? We want to iterate through all these values, right? And then sorry, this is not, we want to initialize these hold on. Yeah, we want to have a 0. We want to initialize this array here, right? And how can we do this? We want to have 26, right? We want to initialize it 26 times. So this is 26. Let's go strings 26. How do you initialize it? Let's do some googling. because of 26 alphabets, right? And then for C, yes, right? You want to iterate through the characters of this particular string. And here we want to make sure that we add something to 1, right? We want to increment 1, and how do we get the index of what to increment? Here is the interesting part of this. We can use, let's see, how do we find how to find ASCII value item of child ordinal function, right? Okay, yep. So we do ordinal of C minus ordinal of A. Alright, this will get us the index because this yeah, I think this should be right, because if this is A, then this will be 0, right? And if this is B, right, for example, if C is B, then ordinal of C, right, equals to $98 or something, right? 98 minus 97, which is 1, which is what I want, right? And ordinal of A, obviously we end up with 1. Yeah. So we have this, and then we increment it with 1. And then once we're done with this, what we want to do is actually to add this particular key, this particular value as a key. But since lists cannot be keys in the dictionary, we need to do something like a tuple of a key, right? Let's change this to letters, right? And then you want to add letters to this. A tuple of array res dot push yeah, this would be the key, right? And the value here would be T itself, the string itself, and then after that you want to return the rest of values. Yeah, here essentially we want to have a hash map here, and we want to have the value here to be like that, and we want to have this thing here. So result tuple key dot append as, we want to push something here, because default it will be an empty list, and you have this tuple as a key. You add this and you return result dot values. So this works. Key is not up. And yeah, we got it. So obviously this is after reviewing and memorizing and kind of trying to recall the solution, which explains how this question is solved. Obviously the first solution that I thought of, the closest I got to, was actually to sort the strings, but once I knew of this solution, it was really genius. And this is just revisiting and trying to recreate the solution from my memory, and hopefully I got it, and thankfully I got it. And it could have been faster, but I think I need to familiarize myself with functions such as, collections such as default dictionary, as well as putting a tuple as a key in a hash map, which is a very powerful thing we can do in Python. And that's all. Thank you for watching.